So now we're going to talk about the steps of how we find a confidence interval for the population mean when we do not know the population standard deviation. The process here is very, very, very similar to the process in the previous example. We will still be finding a point estimate. Our point estimate is still the sample mean because we're still estimating the population mean. And we will still have to then go find an error E that we will move out to the right by adding it, and an error E that we will move out to the left by subtracting it, and that will give us our confidence interval. The formula for E is going to be different in this lesson, however. So to start off, we still need to verify that we do not know our population standard deviation, else we would be in the previous lesson, that the sample is random, that the population is either normally distributed, or that the sample size is greater than or equal to 30. We still need those two conditions to be, one of those two conditions to be true, because this is still based off of the central limit theorem. Remember, it was the central limit theorem that told us that the means of the means are normally distributed. We need the sample statistics N, X bar, and S. That's the sample standard deviation. We do know that X bar is the sum of all the X's divided by the sample size N. And if you remember the formula for the sample standard deviation, it is the square root of a lot of things. It is the square root of the sum of all of the X's minus the sample mean, and all those differences should be squared, and all of this is divided by N minus 1. Now, I'm not necessarily expecting you all to go in and do this formula by hand. I would much rather you just do it on StatCrunch or on your calculator. And we'll see examples of how to do both again, because we have seen how to do that before. Once we have gathered our sample statistics, we need to identify the degrees of freedom. Which I typically do abbreviate as DF. We need the degrees of freedom, we need the level of confidence, and we need the critical value T sub C. We just did a couple of examples above where we practiced finding that critical value. We need to know that the degrees of freedom is always one less than the sample size, N minus 1. Once we know the critical value, we can then go find our margin of error. This is where the new formula comes in. That's different from the previous lesson. When you do not know the population standard deviation, your formula to find the margin of error is now T sub C multiplied by the sample standard deviation divided by the square root of N. So remember, back in the previous lesson, when we did know it, it was this. This was the formula to find the margin of error. Notice that the population standard deviation was now replaced with the sample standard deviation, and then the standard normal score, the z-score, was now replaced with the t-score, something from the t-distribution. So the formulas are very, very similar, but they are in fact different. Once we have our margin of error, we are then able to go and find the left endpoint of our confidence interval by subtracting that error from the mean, and the right endpoint of our confidence interval by adding that error to the mean. Everything down here is exactly the same as it was in the previous lesson. Once you find that error, you move to the right and you move to the left from your sample mean, from your point estimate.